Good afternoon. Today I am going to present about two-layer freedom system, that is spring mass system using MATLAB. So in this topic I am going to take a problem that is 2 degree of product freedom system in which two masses are completely fixed with a fixed support, in which K1, that is the spring mass constant, which is attached to the M1, and the spring mass constant K2, which is attached to M2, in which the base constant, that is the base excitation constant, is attached to, which is known as viscous damping coefficient, is attached to the M1, and B2, that is another constant which is attached to M2. The entire system is controlled or externally forced by external force excitation, which is F, of which respect to T. The T represents the time, that is a function of time, in which the system is moved, that is at time T is equal to 0, that is at initial time at the very which is there is no movement, the displacement x is equal to 0. At certain time, that is that certain time, the displacement, that is the mass system, will be moved because it is finally at base attached with the roller. Therefore the mass system which is moved with a distance of 10 meter, and another M2 which is moved a distance of 10 meter, that is 10 plus 10, which is 20 meter. The entire system is solved, the entire problem is solved by using MATLAB in this video. So in another one, the drawing will be separated or distributed according to M1 and M2. In M1 we have spring mass system and K1 X1. How it is formed? Because the M1 this side, it is attached to the constant spring constant, that is K1, and it is displaced by the displacement X1. So that is K1 into X1, and another one plus in this side which is excited by B1 into X1 dot, that is velocity. Therefore X1 dot velocity. The same will be repeated in the opposite side. In opposite side it is attached with K2, that is X2 minus X1, and B2 which is X dot minus, that is X dot 2 minus X1. The same will be repeated for the another one, but the difference between the two masses will be in mass M1, the left side is attached with the spring and constant, and right side is attached both with the spring and constant. But in M2, the left side is attached with the spring and constant, and the right side is attached with the external force. Therefore, the difference between the two will be measured in the equation form. That is, with this we are going to write the entire system in equation form. That is, in the equation form we take this side, that is the right side will be taken as positive and left side is taken as negative. So in right side we are going to mention as K2 X2 minus X1 plus B2 X2 dot minus X1 dot, and this one is written as the equation, and the same will be written as M2. In the opposite side, that is equal to M1 with respect to acceleration. The X double dot is mentioned as acceleration, and the equation can be rearranged with respect to acceleration will be this one form. The same will be used for the another mass, that is M2. The same equation type is repeated for. So how will we solve this in MATLAB? So that is what I write a coding regarding this MATLAB, in which I show. Wait. Did you see the coding? So in this coding, I represent, that is the spring mass constant, which is K1 is equal to K50. I give the values, and first I define the constant, that is all the constants with values. That is the problem parameters. That is one K1 is equal to 50, and K2 is equal to 50, and B1 3 and B2 3 base kilogram per second viscous damping coefficient B2, and M1 is equal to 5 kilogram, M2 is equal to 5 kilogram, and X1, that is X1. Yeah, I already told in the problem. The first X1 will be at the displacement of 10 meter, and second X1 will be displacement of 20 meter. That is to be mentioned here 10, 20. That is the first initial position and second initial position, and the same will be velocity also. Velocity at first displacement, that is 10, and velocity at second displacement 20, that is 20 meter per second. In which this I added the simulation also. If you want to add the simulation, you can use, or else simply omit the steps. So another one is variable for initial condition. First I have to, because we are using Euler method to solve this problem, so I have to imply the initial conditions to use the Euler method, that is the iteration concept. In iteration concept I have to give the values, that is I have to give the input to all the constants, that is first one X1, I give the x1 is equal to, first I represent the function, that is x1 is equal to zeros iteration comma 1. So therefore x1 is nothing but the zeros iteration comma 1, in which I define its value. x1 1 comma is equal to x10, and same will be applicable to x2, that is displacement 2, and other than the same will be applicable for velocity and acceleration. That is the same concept with different value. And then we have to use Euler method, that is iteration. In Euler method we are using, that is already we defined what is x1 and what is meant by n, that is we have to use two values. N is equal to, that is iteration nothing but 1 to n value, in which the n is taken as 2. So another one is the same, it will be repeated using some iteration concepts, in which both velocity and displacement are considered. That is, for example, we will see the value n1 is equal to 1.001 and n2 is equal to the same value we repeated, because we already solved using the given values. The equations will be solved. So using that, we are going to plot the graph between displacement with respect to time, velocity with respect to time, acceleration with respect to time. So we will get that by using the run. So I am going to run the entire commands to get the final answer. So here we got the function, that is the function, that is the entire function, that is the value that we solved is shown in the functions. Thank you.